In this video, I'll show you 5 examples on how to compute the average rate of change of a function over an interval. But before that, let us recall first what we mean by the average rate of change of a function. Suppose that the blue curve on the right is the graph of the function y equals f of x. If we pick any 2 points on the curve, let's say points P and Q, the line that passes through points P and Q is what we call a secant line. Now suppose that the x-coordinate of the point P is x sub 1. So its y-coordinate must be f of x sub 1. Suppose also that the x-coordinate of point Q is x sub 2. So the y-coordinate of point Q must be f of x sub 2. Now the average rate of change of this function over the interval from x sub 1 up to x sub 2 is just the slope of the line PQ. And so if it's just the slope of the line PQ, then we can compute the average rate of change of this function over the interval x sub 1 up to x sub 2 by getting the value of the expression f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1. The numerator, which is the difference between f of x sub 2 and f of x sub 1, is commonly denoted by delta y. So delta y indicates the difference between the two y coordinates. Also, the difference between the two x coordinates is denoted by delta x. Alright, so this is the formula or expression that we're going to follow in order to compute the average rate of change of a function over a given interval, x sub 1 up to x sub 2. Alright, so let's have now our 5 examples. Example number 1, let's have the function f of x equals x cubed plus 1. We will find the average rate of change of this function over the closed interval from 2 to 3. Alright, so here we can have 2 as our x sub 1 and 3 as our x sub 2. So to do this easily, you can just compute first f of x sub 2 and then f of x sub 1. So f of x sub 2 is f of 3. So f of 3 is 3 raised to 3 plus 1. So that is 27 plus 1, which is equal to 28. Then f of 2 similarly is equal to 2 raised to 3 plus 1. So that's equal to 8 plus 1, which is equal to 9. So the average rate of change of the given function over the given interval is just f of 3 minus f of 2 divided by 3 minus 2. So this is equal to 28 minus 9 divided by 1. So this is equal to 19. So this is now the average rate of change of the function f over the interval from 2 to 3. Let's have the second example. Let's have the function g of x equals x squared minus 2x. Just like before, the first number can be x sub 1, the second one is x sub 2. So let's compute f of x sub 2, f of x sub 2, or f of 4. So this is g already, so we'll be using g instead of f. So yeah, so we have g of 4. So 4 squared minus 2 times 4. So that's 16 minus 8, which is equal to 8. And then g of negative 2 is equal to negative 2 squared minus 2 times negative 2. So this is 4 plus 4, which is equal to 8. So the average rate of change of this function over the interval from negative 2 to 4 is g of 4 minus g of negative 2 divided by 4 minus negative 2. So that's equal to 8 minus 8 divided by 4 plus 2. So this fraction is equal to 0 over 6. So the answer is 0. Alright. Now, let's have example number 3. So now we have a trigonometric function. H of t equals cotangent of t. Okay, here we might need one trigonometric identity to solve the values we are looking for. So suppose this is t sub 1, this one is t sub 2. So here we'll be using the letter t or variable t since the the independent variable is t instead of x. Okay, so we have h sub t sub 2 is h of 3 pi over 4. So let's compute h of 3 pi over 4. So h of 3 pi over 4 is equal to cotangent of 3 pi over 4. Alright, so if you are not allowed by your teacher or professor to use a calculator, then we must rely on trigonometric identities to solve this one. Take note that we can use the identity cotangent t is equal to cosine t divided by sine t. Alright, so this one is the same as cosine of 3 pi over 4 over sine 3 pi over 4. Okay, and then you can just recall the unit circle to find the values of each of these. Okay, so cosine 3 pi over 4 is equal to the square root of 2 over 2 divided by sine 3 pi over 4, which is equal to positive square root of 2 over 2. So obviously this is equal to negative 1. Alright, so we can also solve h of pi over 4 in similar manner. So this is cotangent of 3 pi, pi over, so this is pi over 4 instead of 3 pi over 4. So pi over 4. So cotangent pi over 4 is the same as cosine pi over 4. Cosine pi over 4 divided by sine pi over 4. Cosine pi over 4 is square root of 2 over 2. Again, you can just recall your unit circle to find the values needed. And sine pi over 4 is also square root of 2 over 2. So this is equal to 1. Alright. Now, the average rate of change of this function over the given interval is just h of 3 pi over 4 minus h of pi over 4 divided by 3 pi over 4 minus pi over 4. Alright. Okay, h of 3 pi over 4 is negative 1 minus h of pi over 4 is 1. So the denominator is 2 pi over 4 or equivalently pi over 2. Alright, so this is negative 2 over pi over 2, which is equal to negative 4 over pi. This is our final answer for example number 3. Let's have our fourth example. G of t equals 2 plus cosine t. Suppose this is t sub 1. Again, here we are using the variable t because the independent variable in the example is t. So here the second number is t sub 2. Let's solve g of 2, g of t sub 2. So that's g of pi, which is equal to 2 plus cosine pi. And take note, cosine pi is just negative 1. So this value is positive 1. And then we have g of t sub 1, or g of negative pi. So we have 2 plus the cosine of negative pi. That's equal to 2 plus negative 1 as well. Again, you can just recall your unit circle to find these values if in case you are not allowed to use a calculator. Okay, so this is also equal to positive 1. So the average rate of change of this function over this given interval is g of pi minus g of negative pi divided by pi minus negative pi. So we have 1 minus 1 divided by pi plus pi, that's 2 pi, right? So this is equal to 0 over 2 pi, which is equal to 0. Alright, now let's have our last example. We have the function r of theta equals the square root of 4 theta plus 1. So the interval is from 0 to 2. So let's solve for r of 2. r of 2, take note, this is theta sub 1, theta sub 2. So r of 2 is equal to the square root of 4 times 2 plus 1. So this is the square root of 8 plus 1, or the square root of 9, which is equal to 3. Alright, now we have r sub 0 equals the square root of 4 times 0 plus 1, which is equal to the square root of 0 plus 1, or the square root of 1, or simply 1. So the average rate of change of this function over the interval 0 to 2 is r of 2 minus r of 0 over 2 minus 0, which is equal to 3 minus 1 over 2. So this is 2 over 2, which is equal to 1.